Hey guys, happy Wednesday. Happy day 8 of at home learning. Um, Today we're going to be reviewing section 5. I know we just did it yesterday, so should be pretty fresh. It's a pretty short section, so we're just doing it in 2 days. Tomorrow I will post the answers to your review questions, and then your quiz is going to be on Friday. So, make sure you work those problems tonight that I assigned and check your answers tomorrow. Make sure you take care of anything you're unsure of before the quiz on Friday. So let me know if you have any questions while you're working it or after you've checked it and maybe you got a couple of them wrong and you're not sure why. Just reach out to me and I'll gladly help out with whatever you need. So we'll start with our first example. It's going to be 2 over y plus 1 half equals 5 over 2y. So again, remember our goal here is to first get rid of the fractions by multiplying by the common denominator. And this one, between y2 and 2y, it's going to be 2y for our common denominator. So remember, you divide by the denominator, multiply what's left to the numerator. So 2y divided by y is going to be 2. The y's would cancel. So you have 2 times 2, that gives you 4. Next, we've got 2y divided by 2 is just going to be the y, and y times 1 is still going to be y. And on the next one, the 2y's would completely cancel, giving you plain old 5, and subtract 4, and looks like y would be 1. And there's nothing wrong with that solution. Remember, you do have to check to make sure it doesn't make 0 in the denominator somewhere. This one would not, so that one is going to be a just fine answer. Our second example here is going to be a over a minus 6 equal to negative 2 over a minus 1. The common denominator there, you're just going to mush those binomials together. It's going to be a minus 6 times a minus 1 for the common denominator. If you do that and multiply and distribute, the a minus 6's would cancel each other. So I'd be left with the a times a minus 1. I'll write that one down. And then the next one, the a minus 1's would cancel each other out. So I'd be left with the negative 2 and the a minus 6. So we've got to distribute both of those. This would be a squared minus a. This would be negative 2a plus 12. So I see that I have a squared term in my problem. So that means I've got to set it equal to 0, and I want that squared term to be positive, so I'm going to move everything over to the left side. So I'm going to add 2a, and then I'm going to subtract 12. So it looks like I would have a squared negative 1a plus 2a is positive 1a, and then minus 12, all equal to 0, which is what we want. So we created that trinomial so that we could factor it. And it factors very quickly because there's no number in front of that squared term. My third sign is negative, so that means I'm going to have 1 plus and 1 minus in each parenthesis. And the factors of 12 are either 1 and 12, 2 and 6, 3 and 4. I'm looking for the ones that subtract to make the understood 1. And clearly 3 and 4 subtract to make 1. I need it to be a positive 1, so that's going to be a positive 4 and a minus 3. And now that it's factored, I set each factor individually equal to 0. So a plus 4 equals 0, and a minus 3 equals 0. Subtract 4, and a would equal negative 4. Add 3, and a would equal positive 3. I look back to my original problem. Negative 4 would be fine. It wouldn't make 0 in either denominator. And 3 would not make 0 in either denominator either. So both of these answers are going to be accepted. A third example for you. It's 2 over x minus 2 plus 1 equals x over x plus 2. So common denominator, nice and easy to find. You just mush all of those binomials denominators together. So my common denominator is going to be x minus 2 and x plus 2. So on the first one, the x minus 2's would cancel each other out. So I'd have the 2 times the x plus 2. On the second one, there is no denominator, so I just have the 1 times those two things. So I'm not going to put the 1, but I will still have the two things, x minus 2 times x plus 2. And then on the last one, the x plus 2's would cancel, so that would leave me with x times x minus 2. All right, so I have quite a few things to multiply out now. If I multiply there, I would have 2x plus 4. This one has to be FOILed, so it's going to be x times x is x squared, x times 2 is 2x. This negative 2 times that x is a negative 2x, and the negative 2 times that positive 2 is a negative 4. Don't forget that plus sign. And then on the right side, distribute that x through, and you've got x squared minus 2x. Okay, got a lot of like terms over here on this left side, so I'm going to put all of those together. I see 2x minus 2x in the middle, so those are going to cancel each other out. And I also have a positive 4 and a negative 4. So it looks like I'm left with the x squared and then a positive 2x, still equal to the x squared minus 2x. Okay, now I do have a squared term on each side of the parentheses, so I'm going to move the x squareds to the left, and you'll notice they cancel each other out. So I have 2x equals negative 2x. Get all of my x's to one side, so I would add 2x to both sides. Looks like I have 4x equals 0, which means that x equals 0. So let's see, can 0 be a solution? 0 minus 2 would make negative 2 in that denominator, which is fine, and 0 plus 2 would make 2 in that denominator, which is also fine. So 0 is a fine solution. Looks like it would work. So 0 is our answer there. Let me flip over my page. I've run out of room here. Number 4. All right, we've got y over 2y plus 2 plus 2y minus 16 over 4y plus 4 equals 2y minus 3 over y plus 1. Okay, so I'm looking at each of these denominators, and I notice they all, well, at least the first two, they have a GCF. So I want to think of this as 2 times y plus 1 because there was a 2 in common. And I want to think of this one as 4 times y plus 1 because there was a 4 for a GCF. So then I look at my denominators as they are now, and what would be the common denominator? Well, between 2 and 4, it would be 4. And then they all have a y plus 1 already in common, so I just need the single y plus 1. Okay, so now I just got to cancel things out and multiply what's left. So on my first one, the y plus 1's would cancel each other out. 4 divided by 2 is 2, so I've got 2 times y, that's going to just be 2y. On the next one, the denominators match exactly, so they're just going to cancel each other out, leaving me with the numerator of 2y minus 16. On the last one, the y plus 1's would cancel, so I have the 4 left to multiply to the 2y minus 3. So I'll go ahead and combine those like terms on the left. 4y minus 16 equals, distribute over there, 8y minus 12. So I like to move the smaller variable, so I would subtract 4y from both sides of the equation. Negative 16 equals 4y minus 12. From there, I might rewrite and call it 4y minus 12 equals negative 16. And then it's pretty apparent what to do. Add 12. 4y equals negative 4. Divide by 4, and y is negative 1. All right, so let's see. Look at our denominators, our original denominators. If I look at any of them, negative 1 plus 1 is 0, can't have that. Negative 4 plus 4 is 0, can't have that. All of them make 0 in the denominator, so this answer gets rejected. There's going to be no real solution to that problem. I've got one more example of this and then a couple of the variable ones to look at just to make sure we're all good. Let's see, this one's going to be 4r minus 4 over r squared plus 5r minus 14. And then plus 2 over r plus 7 equal to 1 over r minus 2. So the first thing you should look at once again is that denominator, it factors, so you want to factor it to help you find the least common denominator. It can go straight to the parentheses because, again, there's no number on that first term. My third sign is negative, so I know I'm going to have r plus something and r minus something. The factors of 14 are 1 times 14 and 2 times 7. I'm looking for the ones that subtract to make positive 5. So 2 and 7 are the ones. It's got to be a positive 7 and a negative 2 to make a positive 5 in the middle. So I can ignore that now. And what's my common denominator? Well, the r plus 7 and the r minus 2 are all kind of copying each other. So it's just going to be the r plus 7 and r minus 2. So clearly on my first one, they're going to cancel each other out, leaving me with the numerator of 4r minus 4. On the second term, the r plus 7s would cancel, so I would have the 2 in the numerator times the r minus 2 that's left over. On the last one, the r minus 2s would cancel, so I'd have 1 times r plus 7, but I don't really need the 1 there. I'll just write the r plus 7. I'll go ahead and distribute. 4r minus 4 plus 2r minus 4, not 14, just 4, sorry, equals r plus 7. Combine those like terms on the left. 4r and 2r make 6r. Negative 4 and negative 4 makes negative 8. Get all those r's on the left side, so I'd subtract 1r, giving me 5r minus 8 equals 7. Go ahead and add that 5, or add that 8, I mean, and 5r equals 15. Divide by 5, and r is 3. Look back to your original problem. That would make 10. That would make negative, or that would make positive 1. Those are fine. That would make 10. That would make positive 1. So all of those are fine. None of them made 0. So that is an accepted answer. I've kind of run out of room here, so let me pull out one more piece of paper for you. All right, the last two examples I have are those ones with only pretty much variables involved. So it's the first one, number 6 here, it's going to be t equals 2u over b plus e. We're solving this for b. Okay, so any problem with a fraction, the first thing I'm going to do is multiply by that common denominator to get rid of it. The common denominator, of course, is b plus e because it's the only denominator there is. So I would have t times b plus e equals, those b plus e's would cancel, giving me just the 2u. Okay. Next, you might go ahead and distribute that t, giving me tb plus te equals 2u. If I'm solving for b, that means anything without a b needs to go to the other side of the equation, so I need to subtract te from both sides of the equation. Those don't really go together, so I'll just keep it as 2u minus te. And then next, to get b by itself, you just divide by t to this side, which means this whole side gets divided by t. And there is what b is, 2u minus te all over t. So yeah, one more example of those. The BMI formula, b equals 705w over h squared. Okay, we're solving this one for w. Okay, so again, like the other one, first step is to get rid of the fraction by multiplying by the common denominator of h squared. So b times h squared is just going to be bh squared. The h squareds cancel on there, giving you 705w. And then looks like I just have one more thing, divide by 705. And it's solved for w right there. bh squared over 705. Let me know if you need any help with any of those. Again, work on these problems tonight. You'll check your answers tomorrow. And if there's anything you're missing a lot of, just let me know and I'll help you out. On the page, remember you're doing 4 through 52, the multiples of 4. So good luck. That's 13 problems. Shouldn't take you too terribly long. Have a great day. We'll talk to you later.